Okay, so we will look at how you can use a grid sheet to support, let's say, learning about algebra and algebraic expressions. So let's say I have an algebraic expression. So the distinction between what an algebraic equation and an expression is, there's no equal to sign in an expression. The algebraic expression is just a set of terms. So in this case, this is an x plus y. I might have other expressions. So let's say I have a 2x, and then I have a 3x, and I have an x plus 2y. So what I am trying to do in terms of a distinction between to understand the expression is that x can take different values and y can take different values. So let's say I have x take a value 3 and I take y take a value 5. So how can we represent these in the grid? That's what we want to do. So I'm going to take the first expression, which is x plus y. So x is a length of 3. So if I start from here, I use the color for x and I say 1, 2, 3. So the advantage of the grid line is it doesn't have a lot of distinctions, which is useful also in its place. But when you're starting, that's probably not needed. And then I'm adding to it a y. In this case, it's 5. So that's 1, 2, 3, 4, 5. And now I can have the same expression. I can have different values of x and y. So it means the same expression can take, so if I use, let's say, 4 here, and if I use 2 here, the same expression, when I substitute, will have 1, 2, 3, 4 and 1, 2. So both of this is a representation of the same expression, x plus y. And so addition plus is basically the line becomes longer. So I wrote 4 and 2. So that became 1, 2, 3, 4 and this became 2. So the addition of x plus y are basically lines. They are expressions in which the line becomes longer. So if I have 2x and I have the same 3 and 4, so I have 2x, so that is 3, 1, 2, 3 and then another 3. So that's 1, 2, 3. So this is the regular substitution we do. You write this as 2x where x is equal to 3. You write this as x plus y. Okay, sorry, I could do plus with that. Y, and that is x is the first one, and x is 3 and y is 2. And the second one, x is 4 and y is, sorry, that is 5. 5 and this is 2. Okay, so because one of the things I've noticed recently, and then we practice a lot, you practice the other expressions, you keep drawing them, so you get an idea that there is no an expression can look as different lengths depending on the values of x and y. So it changes. So the idea of change becomes more obvious when you use a grid sheet, and the advantage of that is when people go to, let's say, blocks. So we have all these algebraic blocks. So you have x, which is a certain length, and then you have 1. So I have noticed recently people have been getting confused. What is x here? Is x the area? Is x the length? Because then when they do x times y, let's say that is x and this is y, so they are not able to see this is xy. There's some difficulty because we started off with area itself. So it may be a good idea. So if, let's say, this was x and this was 1, then these are our algebraic tiles which has this area of x, because x times 1 is x. And if this is x and this is y, then this area is xy. No? So we want to get to this. And if we start with at least the linear expression being a line, then going from there to multiplication as area will make sense. So that is one use of this grid sheet that it eliminates 2x is x square, it eliminates xy, how xy is coming. So area you will show as when you have a product of variables, you will show them as area. And when you have just a single variable in an expression, you will show it as a variable length. And that's what we are attempting to do here with the grid sheet, and do a lot of examples to do that. Yeah. So if I had the same, x has a value 3, y has a value 5, but I had x, y, okay, sorry, y with the other color. If I had x, y, a product. So a product is area. So x is 3, so that's 1, 2, 3, and y is 5, so that's 1, 2, 3, 4, 5. Then when I make the shape, I will be able to correlate it with the algebraic tiles, because there are 15 squares. So that is 3 times 5. And they can count the squares, of course, right? So that's 5 and that's 3. So that's 15 boxes. So that's the area. So the product becomes an area. And x square, which is this. So you'll stick with one value for some time and then you'll change the other value. I was just giving examples there. Is clearly different from 2x. This is 2x, where x is 3. This is x square, where x is 3. And this is x, y, where x is 3 and y is 5. So the connection between a length and an area perhaps becomes clear. Now I know 2x could have been represented as 2 multiplied by x. But here we are going to reiterate that if it's a line, let's stay with a line. Till you only when you have a multiplication of 2 variables will you get into area. Okay. So I think this is basically, if we do this, it will help with using algebraic tiles, because there is some confusion with using algebraic tiles.